spiral visualization on graph data. First of all, we will discuss what are graphs. Graphs are V, E, where V represents set of nodes and E represent the edges. The vertices can represent any entity, for example, an individual, and edges represent the relation between them. Some of the examples of graph data are World Wide Web graph. In World Wide Web graph, the web pages, they represent nodes, and the hyperlinks, they represent the edges. In social networks like Facebook, each individual represents a node, and the friendship relationship between those individuals is represent the edges. Similarly, in road networks, the cities represents nodes and the road connections, they represent the edges. Similarly for the airline networks. Next, coming to large graphs. Large graphs are the graphs that contain hundreds and thousands of nodes. When large graphs are represented using node link diagrams, as shown in the representation here, where each node is a circular point and the edge is represented by a straight line, it results in a very cluttered visualization. This visualization cannot be interpreted. For example, a user cannot easily interpret the information like the number of groups present, the edges, the nodes, connections, etc. So in order to solve this problem, we develop a new visualization called spiral visualization with the aim to represent graph data in more readable and interpretable form. The spiral visualization also has a unique feature to represent important nodes in the graphs. Now, spiral visualization. First of all, we will discuss the underlying concepts of spiral visualization. The spiral visualization is constructed using the following steps. First of all is community detection algorithm. A large graph data is taken as input and community detection algorithm is applied. A community detection algorithm divides the graph data into group of nodes. These nodes are more connected within than the rest of the network. So when we get a set of nodes representing the communities, we order the nodes present in each community. The ordering is done based on the importance of the node. Now there are various criteria in which the importance of the node can be measured. These are degree. Degree is the number of nodes to which a particular node is connected. More the degree, more is the importance. The second criteria is closeness. If a particular node is close to all the other nodes in the network, then it is said to be more important. The third criteria is eigencentrality. Eigencentrality, a node is said to be important if it is connected to important people. So there are various ways in which centrality can be calculated, and our visualization tool allow user to select any of the importance criteria and order the nodes based on the importance. So once we have the ordered nodes, we will arrange the ordered nodes in each community in the spiral shape such that the important nodes, they fall in the center of the spiral and less important nodes, they fall in the periphery of the spiral. Lastly, we connect the spirals using the edges. The spirals are connected if and only if the subset of nodes belonging to one community is connected to subset of nodes belonging to another community. To elaborate spiral visualization, we will show you an example. This is an example of spiral visualization on Facebook network. Here each spiral, it represents a community. The nodes in a spiral are ordered based on the importance. As mentioned here, we have used degree as the importance measure. So the centermost node will be having the highest degree, followed by less degrees nodes. Then there's a connection between two communities if and only if the subset of node belonging to one community is connected to subset of node belonging to another community. The thickness of the link, it represents the number of interconnection between two communities. The color of node, it represents the density of the community. Green color represents low density. Yellow color represents medium density, and red color represents high density. Density is the ratio of connections within the community to the total number of possible connections within the community. A user can change, or a user can also change the color coding based on the centralities. We will elaborate this feature through the demonstration.